On the findings of UT2 and S7, so UT2 was a hydraulic fractured valve. What we saw was that in midway of after flow period, the plunger, solid type plunger, started falling prematurely. And you know, solid type plungers are meant to fall in the shut-in period because they are designed in very close tolerances with the internal diameter of the tubing. So if they start to fall prematurely, they will restrict or block gas flow, and it will eventually result in less. You can less flow. You can otherwise shorten the after flow period and increase the number of cycles like we did in the L3. And that's exactly what we did in UT2 also. We realized a gain of 0.2 million cubic feet per day with 200% incremental recovery. Well, S7, we saw that the solid type plunger was not very well suited for this well. We replaced it with a bypass plunger, and we saw about 0.3 million cubic feet per day increase. This well had some operational issues as well, so we are seeing to further optimize it and further add 0.5 million from this well. So that's in plan. So to conclude, we were able to demonstrate successful application of acoustic tracking as a cost-effective and non-intrusive technique for plunger lift optimization and tracking of wells. We were able to make data-driven adjustments, which otherwise would not have been possible with the traditional gas work. And apart from just time parameter adjustments, we were able to understand how different plunger types were incompatible with certain wells, for certain wells. So lastly, the operational recommendations from some of our learnings. The gas guns that you intend to use for plunger tracking, we recommend that they have an enhanced sensitivity microphone that's usually found in the low pressure gas guns. And for the fast moving plungers, we recommend a higher sampling rate. Sampling rate is basically the number of readings being logged in the system per second. So you have the liberty to adjust that prior acquisition. Wherever feasible, we recommend to capture at least 2 or more cycles, because it's always better to report consistent observations, not one-off observations. Lastly, the surface events, as I mentioned earlier, should be marked live by the field teams. We always encourage them to mark them themselves, because they hear it happen, and it's easier for us to interpret. So that's it from my end, and the floor is open if you have any questions, please.
So first question is from my side.
Yeah.
There are a number of techniques for liquid loading. On what criteria you selected this well for plunger lift?
Right. So, we have criteria defined for gas lift ratios. It has to be in a certain range for, packer wells. They had different criteria for packer and packerless wells. So for packer wells, it needs to be around 1,000 to 1,200 units of GLR. But the primary, driver for selecting plunger lift as an artificial lift solution for any well would be the economics, because unlike other artificial lifts, the plunger lifts only utilize the reservoir's energy. So once you drop the plunger, after obviously the surface setup and everything is done, so there is no manual intervention is required. No well intervention is required. When you have to inspect the plunger, you just shut in the well for a few more hours, and you open it, the plunger is at surface, you inspect it, you change the plunger, and that's it. So it has low cost.
What was the status of the well before applying your plunger?
Completely shut in. The wells were completely shut in, yes. The wells were mostly completely shut in. Some of the wells used to struggle. For example, S7, the well used to struggle to flow because it was flowing very near to critical rates. It would, with any slightest change in flow line pressures, it would load up and it would cause trouble to us.
And what optimized production you achieved, and was that sustained?
It's sustaining till date.
Yes. Okay. Thank you. Floor is open for question.
Hello, my name is Nasser from Mari Energies. My question is regarding your acoustic scanner you talked about. Would you please share your experiences where you got more out of that in terms of tubing leak, if you have found out of that? Because sometimes, you know, when, as you talked about the acoustic, there could be a differential acoustics which can be detected. Do you have any experience to find out any tubing leak especially?
So we're using it extensively for well integrity validation and detection, and we intend to write a paper on it as well. We can be developing some case studies. So although not the scope of this paper, but maybe we can discuss it offline. It was also presented as future work in the last paper that we presented. So the applications basically of acoustic service can be your static bottom hole pressure estimation, fluid levels estimation, flowing bottom hole pressure estimation in gas wells or gas lift wells, well integrity validation. So we have a technique called dual survey. What we do is, like, you know, when you pump tracers to identify the point of leak in the tubing or tubular, what we do is we use two gas guns. We hear from one and we fire the other, and we see the point where that acoustic pulse would connect between the tubulars, and we basically determine that to be the leak point. So it's just tracers but with sound. So a lot of other, you know, there's a lot of literature, although we haven't tried it yet, but companies have, I don't know the company name, but they have been using it for pressure buildup surveys as well. So there's a lot of literature available on it, you know, open source.
Yeah, I think that's a reasonable answer that you gave me, but my question was regarding, the same question. Without tracers, so were you able to find the leak without any tracer, only on acoustic signals? That was my question.
But you're talking particularly of well integrity, right?
Yeah, for any tubing leak, if you
Yes.
have.
So for well integrity, you know, detection, pressure data is not very useful. We rely solely on the acoustics.
Let me add. Yes, I'm co-author of this paper. Yes, Nasir, this is here. This acoustic technique, ecometer, we normally use for the integrity identification of those pinholes or the leaks in the tubing, even in the casing also. Depending on the deployment method, either through the casing or through the tubing. Yes, we are using this for the leak detection or the pinhole in the tubing and casing. And also for the restriction in the tubing if you have. Is there any question?
Okay, thank you. Nice presentation.